All right, number 8. We have our picture drawn. The directions ask, find the measure of angle BAC. So we're looking for this angle right here. I'm going to call that X. And it says the figure's not drawn to scale. So the given information we have is we have a circle O, but based on the picture. Looks like a diameter AC. And then we have a point B here where we have a chord AB. We have a radii here, OB, which creates a central angle of 57 degrees with OC. Now, there is a theorem that goes along that basically if we looked at this, we could go right away and say, oh, I know what the answer is, or I know how to calculate it very quickly. What I'm going to do is talk about the background behind it. This is 57 degrees, okay? So if I want to find this angle, so basically this is a central angle, and X is what we call a inscribed angle. It's inscribed in the circle, right? It's on the inside. This X has a relationship with this 57 degrees. I'm going to show you what that is real quick here. So one thing we can do is we can actually notice that what we have here, ABO, is a isosceles triangle with a vertex of O. So that's helpful because we know that this angle here is going to be congruent to this angle here. So what we want to do is find out what those angles are, and this relationship, right, if there's going to be two of these, and if I add this angle to it, I'm going to get 180 degrees because it's a triangle. So what I can do is actually subtract 57 from 180 to get the supplementary angle that's here, and that's going to be 123. And then what I'm going to do is take 123 and subtract it from 180 and get what the rest of these are, because this is going to be X as well. So I have 180 minus 123. Well, that's silly because we just did it, right? That's 57. Is going to be twice X. So that's 57. So 57 is going to be twice X. So if I divide, I'm going to get, what is this, 23.5 degrees is X. Or no, sorry, not 23, 28. Okay. Now, notice what how this relationship happens. This is 57 degrees, right? The sum of these two is going to have to be 57 degrees. Well, that's the same as this, what we call an exterior angle of the triangle. So notice that this is always going to be 180 degrees, always, the total here, right? And if I have an isosceles triangle, these are always going to be double, right, the difference of 180 and whatever this angle is. So what's interesting is that this is the angle, this is actually going to be the sum of these two angles, and then these have to be equal, so this angle and this angle have to be half of this angle here. So the theorem actually says that the angle, the inscribed angle, is half of the central angle with the same endpoints. Okay? So we could basically just say, oh, the central angle is 57 degrees. That means the associated inscribed angle is going to be 28.5. That's half of 57. Okay? All right, that's number 8.